MathKlik.
Mabuhay! How do we solve complete quadratic equations by factoring? This lesson is about solving quadratic equations by factoring. For better understanding of this lesson, I urge you to review thoroughly your lesson in Math 8 on factoring expressions. Let us start this lesson by reminding you that every quadratic equation in one variable has exactly two roots. Recall how we solved pure quadratic equations like x squared minus 4 is equal to 0. We isolated the constant term, applied the square root property, and simplified to yield the roots of the equation. But a lesson in Math 8 taught us that the expression x squared minus 4, a difference of squares, can be factored as quantity x minus 2 times quantity x plus 2. If we equate each of these linear factors to 0 and solve for x, the values of x are 2 and negative 2. The same answers we obtained when we apply the square root property. What is the importance of this observation? If we were able to factor an expression, equate each linear factor to 0, and solve them, then we can also possibly do the same thing to other factorable quadratic equations. The observation suggests that we can use factoring method in solving not only pure quadratic equations, but also in solving complete quadratic equations. For instance, the complete quadratic equation x squared minus x minus 12 is equal to 0 can be solved by factoring this way. First, we factor the left side of the quadratic equation in standard form. The factored form is quantity x minus 4 times quantity x plus 3. Next, equate both linear factors to 0. Then, solve the two linear equations. Thus, the roots of the equation x squared minus x minus 12 is equal to 0 are 4 and negative 3. So, I suggest that you review and master the different techniques in factoring quadratic expressions. Observe that in solving quadratic equations by factoring, the zero factor property is used. This property states that the product AB is equal to 0 if A is equal to 0 or B is equal to 0 or both A and B are equal to 0. So if we say x minus 4 times x plus 3 is equal to 0, we are implying that x minus 4 is equal to 0, or x plus 3 is equal to 0, or both x minus 4 and x plus 3 are equal to 0. Let's apply the zero factor property in solving this equation x squared plus 2x minus 63 is equal to 0 by factoring. Take note that the numerical coefficient of the second degree term or the value of A is 1. For a quick check of the factorability of this trinomial, let's solve for the discriminant. Since the value of D is a perfect square, we are assured that x squared plus 2x minus 63 is equal to 0 is factorable. Let's express this equation in the form x plus m times x plus n is equal to 0 with two conditions. 1, m plus n is equal to 2, and 2, mn is equal to negative 63. Since the product is negative 63, the integers m and n are opposite in sign. Now, think of two integers whose product is negative 63 and whose sum is 2. These integers are 9 and negative 7, which gives us quantity x plus 9 times quantity x minus 7 is equal to 0. I-apply natin ang zero product property. That means we equate each linear factor to 0. Kaya, ang mga roots ng equation x squared plus 2x minus 63 is equal to 0 ay x is equal to negative 9 at x is equal to 7. Gusto kong bigyan diin ang approach na ginamit natin ay applicable sa quadratic equation na ang value ng a ay 1. It is important to emphasize that factoring works when the quadratic expression is equated to 0. Let's study this next example. Solve the equation 3x squared plus 5x plus 2 is equal to 4. Don't be in a hurry to factor the left side of this equation, even if it is factorable. First, express the equation in standard form by mentally subtracting 4 from both sides. That gives us 3x squared plus 5x minus 2 is equal to 0. Now, we factor the resulting trinomial 3x squared plus 5x minus 2. The factored form is quantity 3x minus 1 times the quantity x plus 2. Then we apply the zero product property. Equate 3x minus 1 to 0 and x plus 2 to 0 and solve them. There you have it. The roots of 3x squared plus 5x plus 2 is equal to 4 are x is equal to 1/3 or x is equal to negative 2. I leave you the checking of the answers. Just substitute these values one at a time to the original equation and see if you'll get true statements. For our final example, let's solve the equation 14x squared is equal to negative 8x. Some of you probably have noticed that both sides are divisible by 2x. Don't attempt to divide an equation by a variable. You can divide both sides by 2, but never divide both sides of this equation, or any equation for that matter, by the variable x. Instead, apply the addition property of equality first to get 14x squared plus 8x is equal to 0. Then, factor the left side of the equation. The factored form is 2x times the quantity 7x plus 4. Then, apply the zero product property. This will result to 2x is equal to 0 or 7x plus 4 is equal to 0. The roots of 14x squared is equal to negative 8x are x is equal to 0 or x is equal to negative 4/7. Now, try this. Solve the equation x squared minus 3x minus 10 is equal to 0 by factoring. The roots are x is equal to 5 or x is equal to negative 2. Solve the equation 4x squared plus 21x minus 18 is equal to 0 by factoring. The roots are x is equal to 3/4 or x is equal to -6. For more matitinik tips, just click MathKlik. And please, don't forget to subscribe and click the notification bell for our next video lesson. See ya!